the mass of the electron. But mass of the electron is basically is infinity, not the number which we write in Holiday. Basically, if you go to inside the structure of interaction, the field, and the use of this, the mass of electron in the interactions, for example, it gives you infinity, but it's not infinity. It has a finite part and it has a divergence force. So we call it bare mass, for example, and the divergence force. So what you measure in the lab is the bare mass, actually. Okay, what about here is the same problem. I don't know how we can be sure that, what does it mean actually? What does it mean that to say that minus beta h, what's that? This is the operator, how you can compare operator by number, What does it mean? You can say that the Hamiltonian of the single particle is less than 1. What does it mean? So that is when I told you this is a formula. But we don't go in the detail of this, and we use just the formula. So in the formula you can just replace this and find that. So this is very essential. So next lecture, which we will talk about the examples, I will use this. So I want to tell you the plan. So after this lecture, I told you we will solve 1, 2, and 3 examples. The electron in the magnetic field, the free particle, again free particle, because I want to solve by this matrix method. Of course, the results will be almost the same. And the harmonic oscillator. And we will end this chapter. The other topics from the Patria, we don't teach it from here because it's not essential. And when we finish this chapter, so it remains, basically remain 3 chapters, but 1 chapter I will remove because it's not essential again. So we will work in the 2 chapters more. Each chapter needs I think maybe one or two lectures, basically.